All right, we are live. Three, two, one. I'm left with one more thing to fix. Then make sure I'm making beautiful clips for you that I want you to use to solve questions. All right, great. Welcome, Form 4s. Welcome to our lesson. Uh, we're going to be going through. We are going to be going through the circle theorem, circle geometry, and we'll do everything that you have to know from start to finish. And at the end of this, nobody will ever have a problem with the circle theorems question. So it's called circle geometry, and in circle geometry, you have to know circle theorems. So I know that at some of your schools, Form 4s, at some of your schools, your teacher called this topic circle theorems, right? So circle theorems, these are the ones you use to solve circles. The topic is called circle geometry. And in circle geometry, for you to say you are good, you have to know the 7 circle theorems. So let's go through them and let's master them. So the first thing that you should master, according to your syllabus as well, and what I also know, for you to be able to understand the 7 circle theorems that I'm going to give you. So I'm going to give all of you 7 circle theorems that I need you to master. When you master those 7, we can be able to do any question. So you won't be asked to rewrite it really. They may ask you to tell us which theorem you have used, but you can remember it. Just by saying it, you can vaguely remember. It's good enough. Before we do the 7 circle theorems, I'm going to do 7 parts of a circle. Okay, it's actually more than 7, but I'll do it as 7. So you need to know 7, or I can say 9 parts of a circle. I'll tell you why I said 9. But we'll split it into 7 different circles. So let's go through the parts of a circle that you need to know. Everybody needs to know these parts of a circle for you to understand the circle theorem. So this first video, I will be focusing on the parts of a circle. Then we do the 7 circle theorems. Then we do questions, which are at the bottom of this worksheet or of this page. So we say the first thing you should know is the 7 parts of a circle, or let's say the 9 parts of a circle. The first one is circumference, and circumference is this whole thing here in red, which I'm putting in red. This whole thing, the outside of it, is the circumference. This is called the circumference of the circle. It's all this distance in red, okay? Remember, the circle is this in red, and everything inside it is part of the circle. But then when we just look at the whole line outside, it's called the circumference. Okay, it's going to get harder as we move on. Then we go to the next, which is called radius. Now, when you do radius, you must also know the center of the circle. So center of a circle is a point which is right in the middle of the circle. And when they use the word radius, it's any line. It's not the line that you want, but it's any line that comes from the center. So this is the center, okay? This is the center of the circle. Radius will be any line that comes from the center and goes to the circumference. So everybody knows the circumference. So any line that comes from the center to the circumference is called radius. So this is going to be radius. It's a line that comes from the center and goes to the circumference. So it's a radius. Okay? Diameter is going to be the next part that you have to know. Diameter is now, you need also the center of the circle to be there. It is now a line that starts from one part of the circumference, passes through the center, and goes to the other circumference. Any line that does that is called diameter. So diameter is going to be any line that comes from one side of a circle, passes through the center, gets to the other side. As long as it passes through the center, then it's going to be your diameter. So we need to see the center there for us to see the diameter. Now, this diameter is going to be the only line that can make a circle be split in halves. A circle is split in halves. The line has to pass through the center. Then the circle is split in halves. And that half is called a semicircle. So whenever you see the word semicircle, look for the diameter. Semicircle is half a circle. It is only made by a diameter. Without a diameter, you can never ever have a semicircle. Make no mistake about that, students. Now, the next part you have to know is going to be chord and segments. This is the next part you have to know. The next part of a circle that you must all know is the chord and segments. Now, we're going to have the center of a circle again, which is the point which is at the middle or at the center of your circle. Then you are going to have a line that comes from one part of the circumference to another part, but it doesn't pass through the center. We saw that diameter passes through the center. Diameter passes through the center. But this line is called a chord. So chord is any line that doesn't pass through the center. If it doesn't pass through the center, then it's called a chord. So here it is, a chord. Okay, it doesn't pass through the center. And a chord will split your circle into parts that we call segments. Listen closely. Segments are made by a chord. So when you see the word segment, you look for a chord because it's the one that makes segments. This one, this section, which is bigger, which we are shading, is called the major segment. Major segment means larger segment. Okay, larger segment. And this one is going to be called the minor segment. It's also a segment because it is made by a chord. But it's the smaller one, so we call it the minor segment. Are we together so far? Have you seen the first 4 things you must know? These are things you must all know. Major segment is made by a chord. So when you see the word segment, look for the chord. Then we go to arc and sector. We want to understand the word arc and the word sector. So you should have the center of a circle. Then you should have 2 radii. For you to have a sector and an arc, you must have 2 radii. I don't care what the radii are doing. Having 2 radii, which means 2 radiuses. Plural of radius is a radii. So here is a radius. Okay, and here is another, because they come from the center and go to the circumference. So any line that starts from the center goes to the circumference is called a radius. Now these radii, this one and this one, these radii, they then cut your circle into pieces of pizza. These radii, they cut your circle into pieces of pizza called sectors. So sectors are pizza slices. The small one, the nice pizza slice, this small one is obviously called the minor one. So this is the minor sector. Remember, minor means smaller. Then the larger piece, which is here, is called the major sector. This is the major sector, students. Don't let me down. This is going to be your major sector. Major sector. Okay, so we've seen sectors. They are made by radii. It's a nice piece of pizza. Those are sectors. All right. What about arc? Well, arc is the outside here, the piece of the circumference. So you're going to have 2 of them. Okay. Wait, let me do it like this. Reduce the size. Then I put the other arc in blue here. This is the other arc which I'm putting in blue. The bigger arc is the distance outside. It is the distance outside, like this in blue, is part of circumference. This is called major arc. This is called the major arc. Then this smaller one is red, is called the minor arc. And arc is an important thing because when we have angles, we will look at their arcs. So make sure you have seen arc. It's the part of the circumference. This thing outside here, it's not in the inside. The inside is the sector. The arc is the outside. So here we have minor sector, major sector, and stuff like that. Okay, that's good. Now we are left with two more things to know. Oh, two more parts. Part number 6 is the cyclic quadrilateral. Cyclic quadrilateral is a shape with 4 sides, and listen closely. All 4 sides must be on the circumference. Look at this side. Side 1. Where is it? It's at the circumference. Side number 2. Where is it? It's at the circumference. Side number 3. Where is it? It's at the circumference. Side number 4. Where is it? It's at the circumference. So all 4 sides are sitting or touching the circumference. When you have a situation like this, this is what we say a cyclic quadrilateral. So when they say cyclic quadrilateral, this is what we are imagining. Okay, it doesn't have a side like this, a side which is in the air like this. Sides in the air, a corner which is in, no. All 4 corners, let's say corners, all 4 corners, Form 4s or writing class, listen, all 4 corners are on the circumference. Then we say we have a cyclic quadrilateral. All 4 corners are sitting at the circumference. Then we have a cyclic quadrilateral. Now we have the last one. Where is the last one? Here it is. Okay, I was about to be shocked. Here is the last one. It's what we call the point of contact. So this is the last part that you must all know. What is a part that is called the point of contact? What part is that we call the point of contact? Well, point of contact is made by tangent. So for you to have a point of contact, you must have a tangent. A tangent is a line that just touches your circle at one point. Excuse me, sorry for the glitch. Give me a second. We've done accounting already. Give me a second. So I'll draw the last part. Some parts are lost, it doesn't matter. We said for us to have a point of contact, then we need to have a tangent. Tangent is going to be a line that touches your circle in one point only. So this is the point where your tangent touches your circle. So this line is called a tangent. It is now a tangent simply because it just touches our circle. It just touches our circle. And the point where it touches our circle is called point of contact. Point of contact is the point where the tangent touches the circle. So you have tangent and you now have point of contact, you know. Now you know what a cyclic quadrilateral is. It can't be like this. This is not a cycle. It has to touch all the 4 corners must touch the circumference. All 4 corners must touch the circumference. We now know what arc and sector. We'll be having the center. We need a center. We need to have the center because we need radii. Students, we need radii. This is radius. This is a radius. And here we have another radius. Okay? And this piece of pizza inside is a sector. And because it's the smaller one, we call it the minor sector. Then this other piece of pizza is the bigger one, which we call the major sector. This is called the major sector. Then when we take the distance on the outside, this one in red is called an arc. And this one in blue also is called an arc. In blue, we call it the major arc. Okay, let me change the color so that it doesn't change to blue with the highlighter. This what I'm highlighting in blue is an arc because it is a piece of the circumference. We call it the major arc. Then this one, the minor arc in red. It is the minor arc. So if somebody uses the word arc, don't get confused. You know what it means now. When somebody uses the word arc, they are obviously talking about the piece of the circumference. Then you go up and you're going to deal with the other parts. We said chord and segment. We said chord is a line that doesn't pass through the center. It comes from one side to other without passing through the center. Once it does that, we call it a chord. And it breaks your circle into what we call segments. This is going to be the smaller one, so it's the minor segment. So when we see the word segment, we must look for a chord. Then here, this is the major segment. Major segment. So when you see the word segment, you must look for a chord. Then you go here now. Diameter is a line that passes through the center. This line will be called diameter. Why it's called diameter is it comes from one side of the circumference to the other whilst passing through the center. If it didn't do this, then it wouldn't be a diameter. It is only diameter simply because it passes through the center. And why we love that is when we see that, then we should know that a diameter is the only thing that can cut a circle into halves. And we'll be calling that semicircle. So if we see the word semicircle, we must look for a diameter, a line that passes through the center, coming from one side going to another. Then we have this, the radius. Radius is coming from the center to the circumference. This is called a radius. Then you have the last one, circumference, which is the distance outside. We call it circumference. So students, don't have a problem with any of the parts. The parts of a circle are not a problem for us. Circumference, we are fine. Radius starts at the center. It has to start at the center and go to the circumference. Diameter is from circumference to circumference, passing through the center, and it will cut your circle into what we call semicircles. Then chord is not going to do that. It won't pass through the center. Even if it comes close, it will never touch the center. That will be now a chord. All right. Then we have the arc and the sectors. Then we have cyclic, quadrilateral, and we have point of contact. Then we have tangent. So if you are very good at knowing the parts, then the theorems will be easier. What we are now going into now in the next one is the theorems. Okay. We're about to start the theorems now. Okay. I've made the first clip and I've stopped it. I was talking about the parts of the circle. Now I'm starting the theorems. Are you ready? Are you ready, students? All right. Let's start. Let's start the 7 theorems. All right, writing class, Form 4s. We are now doing the 7 circle theorems. We have seen the parts of a circle. We want to quickly go through the theorems, the circle theorems. Isn't you wanted to do circle theorems? Here we are doing them, the 7. They are 7. So we are doing the 7 circle theorems. Let's see them. Theorem number 1. Angle in a semicircle is a right angle. What does this mean? Angle in a semicircle. When you see the word semicircle, this word we said it is only made by a diameter. So if they say angle in a semicircle is a right angle, there has to be a diameter somewhere. So let's put our diameter. We have this as your center of your circle. Then you have your nice diameter like this. Now the diameter is going to be the one that makes an angle. So this angle is being made by the diameter. The rule says that this angle that is made by the diameter is a right angle. So angle in a semicircle is a right angle. Angle made by diameter is a right angle. That's what we are saying. Angle made by diameter is a right angle. Angle in a semicircle is a right angle. Same question. Do you understand? So whenever you see an angle that is made by diameter, it has to be a right angle. We don't even need to ask. We know that it's going to be a right angle. So please remember, being good at maths, students, superstar students, listen, being good at maths is just remembering rules. So here we are giving each other the rules that we are going to use, and we are not going to break the rules. We'll stick to them. So this is the first theorem. Angle in a semicircle is a right angle, or angle made by the diameter is a right angle. We go to the second theorem now, the second rule. What does it say? Let's finish up our circle. Let's make a circle here. Sorry that it's cut out. This is going to now be between the radius and the tangent. So listen here. The angle between the tangent, we know the tangent, and the radius at the point of contact is a right angle. So the point where your radius will meet the tangent, it will meet the tangent at the point of contact. That angle made there will be a right angle. Let's put it. We know radius, so we do it one step at a time. Everybody here knows radius, and everybody here knows tangent. So let's put tangent. Here is the tangent. Where is the point of contact? Here is the point of contact where the tangent meets the circle. This is the point of contact. And this is a tangent line. They are telling us situations that we will meet in the exam. So here we have our tangent and our point of contact. If we have a radii, a radius, this is the radius. It is a radius that is going to the point of contact. So this radius is drawn towards the point of contact. Remember, radius can be drawn towards anything. We don't care. As long as it starts at the center, it's a radius. So this radius is going to the point of contact. The rule says that the angle here is 90 degrees. Angle between radius and tangent is 90 degrees if it's at the point of contact. So this angle is 90 degrees because radius is going to point of contact. Tangent is passing through point of contact. The angle here is 90 degrees. So you must remember, it's a right angle. It's 90 degrees. This one also 90 degrees. It's a right angle. These are the rules for the right angle so far. So here we've talked about 2 theorems out of 7. Let's look at theorem number 3. So we've seen that angle in a right angle is angle in a diameter, or angle made by a diameter is a right angle. And we have seen that angle made by the radius and the tangent at the point of contact. Hello? Point of contact is just the point where the radius meets the tangent. It's the point where the tangent touches the circle. If the radius is going there, the radius is going to the point of contact. It will meet the tangent there. And when they meet, their angle will be 90 degrees. We are not going to negotiate with anyone. It's a theorem. It's a rule. Theorems are rules. Now we're going to the third one, students. Let's go through. Let's go through the third one. I know you won't let me down. I know that. Here is the third one. Okay, we have 7. We now know the parts of a circle. So this English in theorems will not catch us. We are ready for it. Come on. Let's go for it. So here's the third one, my students. It says that the angle at the center is twice means 2 times the angle at the circumference. So when you come from circumference to go to center, you should multiply by 2, because angle at the center is 2 times the angle at the circumference. If they are, now we are starting. This is the most important. Listen to this. If they are made, subtended means made by the same arc. This means that if their legs are joining the same arc. Let's see what we mean. We are going to follow the legs of every angle. When we are doing this chapter, we should know what arc is subtending it. So every angle is made by an arc, by some type of arc. So if these angles are being made by the same arc, and one is at the center, the other one at the circumference, then the one at the center is 2 times the one at the circumference. Let's put it. Then I will do in questions and show you where they'll try to trick you. So you have an angle going to the center. And this angle if you follow the legs, one leg will be going to A, one leg will be going to B. So look at this first leg. It is going to point A. The other leg is going to point B. So what you say in maths, you say that this angle, if we call it theta, this angle theta is being subtended by arc AB. It is being made by arc AB because one leg is at A, the other one at B. So it is being subtended by arc AB. I hope you have heard me. This is what we say. I'm teaching you what we say. We say the angle is made by arc AB because one leg is at A, the other one is at B. That's a very important thing. Now, if we then come and take one leg and go there from A and another leg from B again to go there, then we make an angle. So look here now. This angle, if we now call it theta, let's call this one theta now. Theta, what arc is making it? What arc is subtending theta? Subtending means to make. What arc is making theta? You follow the legs. One leg goes to A, the other leg goes to B. So theta is being made by arc AB again. Theta is being made by arc AB. Okay, what about this angle at the center here? It is being made by arc AB again because one leg is at A, the other one at B again. So this is the situation we are talking about. We have an angle that is at the circumference. This angle is at the circumference. The other one is at the center. And both angles are being subtended by the same arc. They are being made by the same arc, arc AB. So what we know, automatically we use this third rule, which says the angle at the center is 2 times the angle at the circumference. So this is theta, so one at the center will be 2 theta. It will be 2 times the one at the circumference if they are subtended by the same arc. So they are subtended by the same arc and in the same segment. We should finish this. If they are subtended by the same arc and are in the same segment, then we know that these two angles, this is what you say. Angle at the center is 2 times angle at the circumference. If they are subtended by the same arc and are in the same segment. And are in the same segment. Don't let me down. Let's keep going, students. You're doing fantastic. Now let's do theorem number 4. We have 7, so you are remembering them. You are seeing them one by one. You have seen that the angle made by a diameter is a right angle. You have seen that the point where radius meets tangent at the point of contact. We know the point of contact. It's the point where the tangent meets your circle. So if radius is going there and the diameter is there, we know that they will make a 90-degree angle. We have established that. And we now know that angle at the center is 2 times the one at the circumference if they are subtended by the same arc. Then now we go to the 4th one out of 7, okay? Once we know the 7, we are done. So this is a 1-day topic. It's not a 2-week topic. You could have done it in 2 weeks, but you didn't have to. You can do it in a day because you just have to know the 7 theorems and then practice and practice and practice. So here we have this, the 4th one. It says that angles subtended by an arc at the circumference that are in the same segment are equal. So listen, everybody. Angles subtended by the same arc now and both being at the circumference. So here we had angles that were made by the same arc, but one was at the center, one was at the circumference. Now these angles are being made by the same arc and both are at the circumference. So let's do it. Here is the center. You have an angle. Here's the center, okay, of our circle. Then let's say you have an angle like this. Then you have another one like this, in black. And this is point A. And this is point B. Now, this angle we'll call theta. This one we'll call alpha. What we know is that theta is equal to alpha. Why? Because both of them are at the circumference. That's point number 1. Okay, they are at the circumference, both of them. They are at the circumference. Okay, that's nice. Both are at the circumference, and both are subtended by the same arc. Let's see what arc is making angle theta. You follow one leg, it goes to A. You follow the other leg, it goes to B. So angle theta is being subtended by arc AB. That's great. What about angle alpha? You follow one leg, it goes to A. You follow the other one, it goes to B. So angle alpha is also being subtended by arc AB. And both of them are at the circumference. Now the last one is they must also be in the same segment. In other words, we know that the word segment comes from a chord. So if we were to put a chord here, okay, we can put a chord for illustration. If we were to put a chord here, then look, both of them are above the chord. We don't have one being below the chord, like one being here. No, both angles are on the same side of the chord. So that means they will be then equal. Are we together? Then they will be equal. So now theta is equal to alpha. This is the rule. Then now you do theorem number 5. So we've seen two angles both being at the circumference, and we've seen that those two angles both being at the circumference are going to be equal to one another. So we have seen the first 4 theorems. Now we need to look at the last 3. Okay, now we need to look at the last 3 theorems. Let me stop the recording and start a new one. All right, so here we are looking at the last 3 theorems, and we'll be done with the circle theorems. All we will be needing to do is the questions now. So let's put the last 3 theorems very well, and let's finish it off. Let's finish it off, students. So theorem number 5 out of 7, what does it say? Theorem number 5 out of 7 says opposite angles in a cyclic quadrilateral are supplementary. Right, so let's master this. Opposite angles, number 1. In a cyclic quadrilateral, let's put one. Let's put a cyclic quadrilateral since we know it. Here is a cyclic quadrilateral. Here is an example of a cyclic quadrilateral. A shape with 4 corners being on the circumference. All four corners are on the circumference. Now, this is a cyclic quadrilateral. Opposite angles, so if I take this to make it theta, then the opposite will be this one, which is alpha, because they're opposite each other. And if I call this x, then the opposite will be y. These are opposites. So opposite angles are supplementary. Supplementary means add up to 180 degrees. They add up to 180 degrees. This is a rule. So you'd say theta plus, okay, students, theta plus alpha gives us 180 degrees. Then x plus y also gives us 180 degrees. Don't let me down. Don't let me down. Don't forget this one. These are easy, students. We can do this in no time at all. We're only left with 2. Can you see this? Wow. That's record pace. Normally you'd think it takes 2 weeks. No, it doesn't. There are just 7 theorems. So why would it take you 2 weeks? Why? So here, let's go for it. Two tangents drawn from an external point. This is theorem number 6. What does it say, theorem number 6? 2 tangents that are drawn from the same point outside, and they are drawn to the point of contact, they will be equal. So tangents are drawn from the same point, so we can call this point A. The same point outside, any point outside. Then we draw 2 tangents. One will come like this, obviously. Then touch your circle, you stop. This is a point of contact, so we'll call this point A. Then we draw another tangent. It touches our circle. This here is a point of contact. We'll call it point B. We won't make the tangent continue because we just wanted to touch the circle. So it just touches the circle like this. Then we stop. We don't continue. We stop at the point where it touches the circle. This rule to be correct, you must stop. Stop your tangent. Where should I stop it? At the point of contact. So we have stopped it now. Now we have been told that tangent 1, this one, is a tangent because it touches the circle. Tangent 1, we have been told that it is going to be the same as tangent number 2. They are going to be equal, so we put it like this. So tangent 1, you write, students, don't let me down, you write tangent 1 is equal to tangent 2. They are equal. Why? Because the tangents are being drawn from the same point. They are starting from the same point and they are ending at the point of contact. They are not passing it. So it makes the two tangents equal to each other. So these two tangents are equal. They are equal. Now one last one, okay, before we do questions. It is here. This is the one that a lot of people leave out, okay? This is one that a lot of people leave out. A lot of people know 6 theorems. They don't know 7. They love to leave out this one. Let's quickly do it and let's talk about it. Angle between a tangent and its chord. Right, let's move slowly. Angle between a tangent and its chord. So let's put tangent. The moment we hear the word tangent, we should put it. Here is tangent. Okay, here we don't have to stop drawing it at the point of contact. We are just doing a tangent here. Then there is a chord, so we must put the center here. The center of the circle is there, but then there is a line which is a chord which is going to the point of contact. This is the point of contact here. Point of contact. This is the point of contact. And here we have a chord. Students, here we have a chord. So now we have a chord and we have a tangent and we have the point of contact. It's no longer a radius here. It's a chord. So they're saying the angle between a tangent and the chord at the point of contact. This angle here, which we'll call theta. You see, we are able to see the picture because we understand the words. We understand the words. The words are not hard for us. This is theta. Angle between chord and tangent. Okay, is equal, okay, to angle subtended by the same chord in the alternate segment. Oh, it is equal to the angle that this chord will make. So this chord, if this point is called point A, then the other one called point B, then this chord is called chord AB because it comes from A to B. Now this chord AB, it is just the same as arc AB. Arc AB though will be the outside. Chord AB will be just this line, but it's the same thing. So now this chord AB, this angle, where is this angle? It is kind of sitting in the minor segment. Remember, this is the minor segment. But they said this angle, it is going to be the same as the angle the chord makes in the other segment. So we now go to the other segment because this angle theta was between chord and tangent, but it was in the minor segment. Now we want angle that the chord makes. The chord subtends because they say it's subtended by the chord. We now want the chord, the angle that this chord can make. This angle here, if we call it alpha, you will know that theta is equal to alpha. Theta is equal to alpha. What are you saying? We are saying that this angle alpha is the same as this one because it is an angle made by a chord and that chord is subtending, or we can say that is the angle made by the chord or subtended by a chord, and the chord is also making an angle with the tangent. So this angle between chord and tangent is the same as the angle made by the chord. That's just what it's saying in short. The angle between chord and tangent is the same as the angle made by the chord. What is the angle made by the chord? Angle alpha. Because one leg is at A, the other leg is at B, so it's being made by chord AB. So these are the 7 circle theorems. This is the hard bit. This is the hard bit. You can know them. The angle between a chord and a tangent is the same as the angle made by the chord. You see, angle between chord and tangent is the same as angle made by the chord in another segment. That's it. Now we say angle with tangents that are drawn. This has nothing to do with angle. It's everything to do with tangents. It has nothing to do with angles, this theorem. It says tangents coming from the same point. If these tangents stop at the point of contact, okay? This is a point of contact. Point A, it is a point of contact. Point B is also a point of contact. So tangents drawn from the same point outside to the point of contact are equal, the tangents. Then here, opposite angles in a cyclic quadrilateral are supplementary. They add up to 180 degrees. What adds up to 180 degrees, my friends? The opposite angles in a cyclic quadrilateral. They are not equal. They add up to 180 degrees. Don't twist these theorems to make them fit your imagination. They add up to 180. Opposite angles, the opposite ones. Okay, and I'll show you where that will come in very handy. This one is the angles made by the same arc. If they are in the same segment, then they will be equal. So these angles are made by the same arc. They are both at the circumference and they are in the same segment, so they will be equal. Here, the angle at the center is twice the angle at the circumference. If they are made by the same arc, you see that they are made by the same arc, you double. Then we have the last two. Angle between radius and tangent is 90 degrees. And angle made by a diameter is 90 degrees. So here are the theorems. I know you're not going to let me down. These are the 7 theorems, and I hope you have mastered them. Have you mastered them? Have you mastered them, everybody? Now let's go to questions, and let's see how we actually answer the questions. These are all past paper questions. These are all past paper questions. Right. Let's go for the question, students. 3, 2, 1. All right, so now we are going to try and quickly do some questions from past papers, and let's see if we're good or we are not. Okay, this is the acid test that checks if we're good or not. Here's the first one. Now, let me tell you something about this. This is a trap, okay? Because when you look at it, you're going to think that you have been given a cyclic quadrilateral when you're not. You have not been given a cyclic quadrilateral. You have been given nothing here. So you can't say the cyclic quadrilateral. By the way, I want to remove the word same segment here. They don't have to be in the same segment. They don't have to be. They just has to be one at the center, the other one at the circumference. So anyway, let me now say this. When you get a situation like this, what you're going to do is, look closely, everybody. When you get a situation like this, you should make a cyclic quadrilateral first. Come on. Make a cyclic quadrilateral. Right. Here is our cyclic quadrilateral now in blue. All the 4 corners are on the circumference. So all the 4 corners are on the circumference. Now we can find this angle theta. We can ignore this here. We can ignore this. What we know about a cyclic quadrilateral is that opposite angles are equal. So 115 and theta are they're supplementary rather. They are not equal, they're supplementary. So the opposite angles are supplementary. So what we know is that theta and 115 degrees should give us 180 degrees. We know that. So to get theta, we'll we'll say 180 degrees minus 115 degrees. Then what are we going to get? We are going to get 65 degrees. This is the theta. But it's not the angle we're looking for. Now we have theta. We can ignore this now because now we can see the picture which we know. We have angle at the center. Then we have angle at the circumference, which we got to be 65 degrees. So this is the angle, 65 degrees. Right. So now what we know is that angle at the center is twice angle at the circumference. So W is going to be 2 of 65s. And you're going to get it. This becomes 130 degrees, 80 degrees as your W. Well done. So this is how you're going to be doing the questions, eh? This is going to be the first question. Now we'll go to the second one. So my time has killed me. My time has killed me. This is so unfair. All right, it's fine. My time has killed me because I also have lessons with the A levels. So I'll just go 5 minutes over time. Let me do this one, and I'm going to give you to try. I know that you need me to do more past paper questions. You have just seen the theorems. I'm going to need to do past paper questions with you and then give you over to try. But anyway, let's quickly apply, okay? Let's not be hesitant. Let's apply the theorems. Our thinking is governed by rules. We are not wild mathematicians. We are true mathematicians. We use rules. So here's what you do. Let me tell you how you answer circle theorem question. Listen to me. Listen to the rules. I know you do it, okay? You're smart enough. Just listen to the rules, then you go and do it. Here's what you do. Never look for what they ask. What you should do, many times what they ask, you can only find it in the second step. Sometimes you can find it in the first, but many times you can't. So here is what you do. Always, before you look for what they ask, put what you know. Did you hear me? I know that I'm training a true group of soldiers of maths. Listen, students. Listen to what I'm saying, then go and apply it, and I'll be so happy. Don't look at the question. There is nothing for you in the questions. Don't look at the questions. Look at the diagram. So I'm not going to look at the questions. I'm going to look at the diagram, and I'm going to put everything I know. Number one, let's take these angles. Angle 41 degrees. Okay? You should follow its legs so that you know the arc that makes it. It is made by arc AB. Okay? You need to know the arcs. We love arcs. So we have followed this angle. It is made by arc AB. Now I ask you, does arc AB make any other angle? Okay, we have taken an angle which we are given. We are not looking at the question. We are using the diagram. We have seen, we have 41 degrees. So we follow its legs because they've given us. And we've seen that it's made by arc AB. Does arc AB make any other angle? Yes, it does, sir. Arc AB makes angle X. Oh, really? Yes. Where is angle X? It's also at the circumference. So automatically we know that it's also 41 degrees. Because the angles that are at the circumference together, if they are made by the same arc, and if they are in the same segment, then they are equal. What do you mean they're in the same segment? Isn't you have arc AB? So you can also have chord AB. Chord AB is here. Look, chord AB, it shows you that this is the minor segment and this is the major. And you can see that both this 41 and this 41 are in the same segment. They're at the major segment. And they are made by the same arc, so they are equal. And they are both at the circumference, so they are equal. All right, good. So we have used 41 degrees. Now, can we do anything? Look at 37. Can we use it for anything? What is making 37? This chord. 37 is being made by chord and tangent. Now we know that this is theorem number 7, which a lot of people run away from at many schools and places. They run away from this theorem. We don't run away from it. Why would we run away from it? We know it. Let's do it. So this is 37 degrees. We know that it is the same as the angle that the chord will make. So what chord is this? This is called chord AD. Where does chord AD go? It goes to angle Y. Everybody can see that one leg goes to the other one. It goes to angle. Now this angle here is the same as this one. Okay, because it's the angle made by the chord. So this is 37 degrees. without even reading any questions. So lucky for us, we have found both answers. Sometimes you would have just found part of the working. So we already now know that this is 37 degrees. We have seen it here, and we know that x is 41 degrees. So the secret is, don't let the answers lead, the questions lead you. If the questions lead you, you're going to get stuck, because they are trained to make you get stuck. Questions 99% of the time are to make you get stuck. So if you want to get them correct, then don't follow the order. Do your own order. So anyway, is this not the same question we just did? It's the same question we just did, this one. Find the value of W. We can find it as well. We know that we just make it a cyclic quadrilateral. Don't be a student that quickly forgets the steps we agree on. Cyclic quadrilateral, we call this theta. Now we know that these angles are supplementary. So we say that theta plus 115 degrees gives us 180 degrees. And we will say that theta will be 180 degrees minus 115 degrees. We get 65 degrees. Now we have this angle, it is 65 degrees. Now we can ignore this one. We will use W and 65. Don't force things. Use correct rules. Now you can use them. This rule now allows you, because look, 65 degrees, this angle, it is made by arc PR, because one leg is at P, the other one at R, so it is made by arc PR. This angle W, one leg is at P, the other one leg at R, so it is also made by arc PR. And it is at the center. The other one is at the circumference. So we know that the one at the center, W, is 2 times the one at the circumference, so 2 times 65. Then you would just say W will be 130 degrees. So we already have the answer, 130 degrees. Yeah, you're not going to let me down. You're going to use this principle. So follow the arc. Put all the information you can put. Then you answer the question they want a bit later. Okay, don't be in a hurry. If you're in a hurry, we'll have a problem. Look here, students. I don't even read the question. I don't want to read the question. I'll get stuck. I'm going to look at 64. What do I know about 64? I'll follow his legs. One leg is at A, the other leg at C. So it is made by arc AC. Angle 64 is subtended by arc AC. It's made by arc AC. Is there any other angle made by arc AC? Oh, this one. Angle at O, it is also having one leg at A, the other leg at C. So it is also made by arc AC. And this one is at the center. Look at this one. It's at the center. This one is at the circumference. So we can say this is 2 by 64. Let's call it theta. We are going to come and say theta is going to be 2. We say angle at the center, that's theta, is 2 times the one at the circumference, 2 times 64. So that means this is going to be what? 136 degrees. Oh, 138? What is it? Let's see. 128. 128, sorry. 128 degrees, right? 128 degrees. That's theta. So we can come here and say you remove theta, you say 128 degrees. You have 128 degrees. Now, what can you know? What can you put here? Everybody knows that these are equal here. These two are equal, right? This and this are tangents. So we say that the tangents are equal. All right, that's fine. If these are equal, what can we put? Let me see. The max help us. Value of x. Let me think. Give me a second. Base angles of an isosceles triangles are the same. Okay, good. I'm seeing things. Right. You know what I thought? Let me tell you. I thought in my mind, because I'm using the rules only to think. I saw that these two are equal. So we have never been told any rule about how to find x. We have not been told any rule about how to find x. But what we know is that we can make a triangle. Look here. This is 128 degrees, right? There are shortcuts. There are many ways. If you have a different one, you use it. But look at this. We can make this into a triangle. Okay, I'm going to tell you a true one. This is 128 degrees. We can make this into a triangle. Now, what do we know about this type of a triangle? We know that the base angles are equal. We know that the base angles are equal because it's an isosceles triangle. There's one thing about isosceles triangle, its base angles are equal, right? So this angle is y and this one is y because this is an isosceles triangle. And this angle would be, if I call it t, and this one will also be t. So for me to find t, there are many ways. Look, I can know that this is a 90-degree angle. There are many things you can do. Let me tell you what you can do also. If you say you can find t by saying 180 minus 128, then you get an answer. Then you say 2t will be equal to 180 minus 128, which is an answer. Or you can say, since you have found this, listen, students, since you have found this to be 128 degrees here, you have found it to be 128 degrees, you also know that when tangent, because once you see this, you see that it's a tangent. When tangent meets a radius, this is a radius here. We all know that when tangent meets a radius, it's 90 degrees. So this is 90. This is also 90 because we've said it. We said we cannot pretend we don't know that. Radius, when it meets tangent, it also does 90. So this is 90 degrees. This is 90 degrees. This is 128. So now we can find x. Because we now have a shape with 4 sides. A shape with 4 sides adds up to give you 360. It adds up. All shapes with 4 sides add to give us 360. So now I'll say x, okay, we are using circle theorems only. X plus 128 degrees plus 90 plus another 90 should give us 360. Now I can find x. X will be equal to 360 degrees minus, then you add them in the bracket. 128 plus 90 plus 90. All these will subtract together. What is x going to be? What is x going to be? Can somebody punch in the calculator exactly like this? Somebody punch in the calculator exactly like this and tell me what you get. So you're looking and you're applying the theorems. You are applying. You're not scared. You see a radius. You see a tangent. These are tangents, these lines. Okay, so you get 52. 52 degrees. So this is going to be your angle. This is 52 degrees. It's your answer. Now you can keep going and I want you to try. I'm going to give you a worksheet from this. These are past paper questions that I just gathered together. You can already see this is October, November 2024, paper 42. So I'm going to just give you a worksheet just now, and I want you to solve the worksheet as much as you can, applying the rules. You try, then I'm going to give you solutions as well. So we do the videos together. I've just been making videos for you. I was live and I was also making videos. So live is one big thing, but the videos are in parts. So every question I recorded it separately. I made a video on the parts of a circle. I made a video on the 7 circle theorems. So that's how we're going to be doing. That's the videos I've been making as well for accounts and economics. So I'm spreading it out consistently. Every minute I'm making videos for you guys. Accounts team, you text me after the lesson. Economics team, text me after the lesson. Maths team, get ahead and start doing this. I know you can do it, okay? So let's push. We use the website very much so. So I'm going to post the videos on the website in the evening after I do my A-level lessons, okay? So I'm going to do the A-level lessons and then I'm going to, afterwards, post these videos together with the ones I'm making for you guys. I'll be with you like I promised. You're going to see it throughout your exam period. So don't worry. Making videos for you, doing whatever you need to make sure everybody in here gets the results. We can make it. But here's the thing, don't be scared, okay? Go and start practicing. Get stuck, then I'm going to give you videos to help you. Thank you so much, everybody. It's time. Goodbye.